thank you very much. I am Sara Pellegrini, and I work for AxonIQ, that you probably heard about in relation to Axon framework. And today I would like to tell you a little about my experience with domain-driven design, CQRS, and event sourcing. And I would like to explain to you how the path I followed in this year helped me discovering how, despite these techniques are excellent taken individually, they can be even better used synergically. Before I go into details, I would like to explain you some reason that some years ago brought me to use domain-driven design. And definitely one of the main reasons was the ever-increasing complexity that is necessary to manage software system. And also the customers who becomes more and more demanding in requesting rapid changes to requirements in order to obtain competitive advantage. And the increasing complexity makes application maintenance more and more difficult. So we also need systems that can be developed in parallel with multiple teams that should be able to release independently. We need the techniques to reduce the risk in developing new features or in changing the current ones in order to be able to work rapidly. And we could say that all this stuff, all these needs can be summarized in a word, that is agility. But there is more. The great popularity of distributed systems, supported and increased by the widespread use of cloud computing and virtualization, and the need to manage application with huge amounts of data, and increasing customer demanding in terms of performance, all of these take us towards the implementation of clustered systems, which can guarantee stability, resilience, and reduce the risk in operations. We could say that all of these needs can be summarized in general with another word, that is scalability. And in a nutshell, we can say that ultimately, in writing our software, we should do all we can in order to employ best practice that allows us to achieve the goals of scalability and agility. And domain-driven design, without any doubt, has helped me in achieving these goals, so writing better software, more maintainable, loosely coupled. And the most important aspect that domain-driven design introduces, in my point of view, is the concept of bounded contexts and ubiquitous language. So the bounded context represent a first form of high-level decoupling. The key aspect of the bounded context is the fact that within this boundary, it is possible to use the same language without any ambiguity. And the exceptional merit of domain-driven design, in my opinion, is that it faced the real problem in software development, and maybe not only software development, the communication among people, the process of knowledge transfer, which start from the use of a common language. So communication is one of the most difficult and complex activity. The communication is strongly influenced by the fields of experience of the subject. And the field of experience represent the sequence of events that have characterized the life of the source and the recipient, and which have determined the ways in which everyone is able to transmit and interpret information. So typically the field of experience of domain experts and developers are really different. And to complicate the matter further, the fact that the humans communicate with both analogical and numerical languages. The numerical language is used normally to exchange information. The analogical one defines the relationship among people. So therefore, every communication contains a content aspect, the news, the data, and an aspect that defines the relationship between the subjects. Sometimes we are faced with a discrepancy between analogical and numerical languages. Body language speaks the truth, and betrays what we don't say with word. Look at an example. So obviously, John doesn't want to communicate exactly that a green light has lit up. His real message is, come on, it's time to move. And Jane is not really asking who is behind the wheel, but the real message is, shut up. So now I guess that based on direct experience, everyone knows how communicating is a very difficult job in itself. And let's imagine what would happen if we didn't use the same language. So the concept of bounded context and ubiquitous language highlight in the first place the need to discover new techniques that can be more effective than those in the past in order to optimize the process of knowledge transfer, the process of learning the domain. And the domain-driven design also introduced another concept, the aggregates. The aggregates imply the definition of boundaries inside our system, so they represent a form of decoupling within the bounded context. And obviously, this approach is very useful in order to obtain high cohesion and low coupling. But we must be careful because the true power of boundaries reveals itself if we are able to stick to these boundaries in every interaction. So often it is not easy to operate within the limits of the aggregate during each interaction. We can think, for example, every time we need to show a view to make a query that requires to retrieve the data from more than one aggregate. So the domain-driven design does not give us any suggestion, explicit indication on how to properly behave when we have to deal with operations that simultaneously involve several aggregates. And then we have the domain events. So although they are never explicitly mentioned in the Blue Book, the domain events combine perfectly with the principle expressed by DDD. And these events represent the facts that occurred within the application domain and can be effectively used to implement the communication among the various components. The great advantage derived from the use of domain events for communication between components is that it provides a temporal decoupling between them. So indeed, if the component must invoke synchronously another component's API, it is necessary to have both of them available at the same time in order to complete the operation. Otherwise, with the use of domain events, the first component is able to complete its portion of logic simply with the publication of one or more events. And it doesn't care about the availability of the second component. The second component listens to the event, and as soon as it receives it, it takes care of managing it. So the two phases can occur with a certain delay as the communication is typically asynchronous. And to make temporal decoupling truly effective, it is essential for the second component not to have to query the first one in order to obtain indispensable information for managing the event. So on the contrary, the transmitted event should be able to provide all the information needed for its management, or otherwise the second component should maintain its own copy of all the additional information needed to handle the event. And it is important to underline that, as a matter of fact, the coupling is only temporal. So the dependence between the two components still exists. It is simply inverted. So it is no longer the first component that know the API of the second one, but it's the second one that expects to receive an event with a specific structure. And this type of dependency is more deceiving than the first one because it is less explicit, but it is certainly a dependency, so a marriage between components. In some cases, when the components interested in a given event are multiple, this can lead to a sense of loss of control. It is certainly more challenging to find in the code all the effects that a given operation will be able to produce, since the entire functionality is distributed in several components. Indeed, we have always been used to having a complete control over our application, adopting a complete transactionality, able to guarantee that an operation is performed completely and correctly, or it is not performed at all, and knowing exactly in advance all the side effects that a given operation involves. So this concept no longer works. And transactionality is guaranteed only for the single aggregate which represent the border of the consistency. And how not to mention the boogeyman, the eventual consistency. So asynchronous communication between different components provide us with many advantages in terms of performance and parallel executions, but this makes domain-driven design a perfect technique for developing distributed system. And on the other end, the behavior of our application turns out to be eventual consistent. Although I've never come across any case where it could be a real problem, at least during my experience during developing DDD, this concept has over the years created strong fears, and sometimes this fear even prevented the usage of the technique. And despite the widespread success of domain-driven design in the last 10 years, there are still a lot of technicians and companies that consider still very hard this mindset change. And we have seen, in addition to the advantages that domain-driven design provide, also some open points, we can say open points, difficulties, introduced by the adoption of this practice. So for the moment, let's point for later, and I would like to introduce the second element that is able to support us achieving the goals of agility and scalability. That is the pattern CQRS. So the common query responsibility segregation, as we know, establishes the use of two distinct separated models for writing and reading logic. And the creation of two autonomous and dedicated models guarantee some important benefits in terms of performance and maintainability, but also some other pros, like, for example, the ability of scaling read models in a totally independent way. But the most important benefit, in my opinion, is that CQRS allows us to focus on reasoning in terms of business process rather than in terms of data structure. And the first important advantage of this is the fact that it allows us to concentrate only on what it is useful right now, putting on what it is not an immediate priority. And normally, as technicians, we were used to think in terms of data structure. We were used to working from scratch on the definition of the specific data model that is more suitable to represent our business domain. And this modeling approach usually consists of the following steps. So during the initial phase, we figure out which entities are involved in our domain. And after, we define the existing relationship between entities. And only at the end, we are going to consider the behavior and the interaction that these elements will have over time. So focusing on the process instead of the data structure means reversing this way of working, starting from the definition of the behavior and leaving the definition of the state last. So reasoning in terms of process also considerably simplify the communication between technicians and business people, since our brain is designed for working in this manner. So it is known that storytelling, for example, is a practice that is extremely effective in conveying information. And we have several practical examples of this, starting from specification by example using behavioral-driven development. Modeling starting from the behavior means, firstly, to identify the commands, events, and queries as basic elements of our process. Secondly, to define relationship among these elements, and in other words, to figure out how these elements must be combined to compose correctly our process. And only at the end, and as a result of the first two phases, we can define the resulting data structure. All of these fit perfectly together with the use of modeling techniques such as event storming by Ziobrando or event modeling, which facilitate and empower the communication between domain experts and developers. And these are some of the most important advantages of using a CQRS pattern. I would like to add one more, which isn't directly derived from the pattern itself, but from the specific implementation of CQRS that we use in Axon Framework. In Axon Framework, commands and queries are implemented as explicit messages, exactly like events. And this generates many advantages, among which an important one is the improvement in the maintainability of the code, making simple and natural writing test cases. Indeed, if the specifications are expressed in terms of processes, it becomes natural to test the software implementation with the pattern given when done. Let's have a look at what happens if we want to test the right model. So given an initial scenario, which consists of a sequential list of events, when a specific command is sent to the aggregate, then I expect from how the command is handled that one or sometimes even more than one event will be generated. So that is a story. And this is doable based on what we have said before, since the current state can be entirely determined on all the events happened previously. And in the same way, we can test a projection. So given an initial scenario, like before, made up of the initial sequence of events, which are already occurred, when a query is made, then I expect to obtain a certain result. So in this way, the concept of command, query, and event become a fundamental part of our ubiquitous language and represent the API of our component. So as we have seen, the CQRS pattern guarantees many advantages, but it also provides some weaknesses. So first of all, we must consider the infrastructural complexity derived from the management of three different types of messages that are events, commands, and queries, which by their nature require implementation of different routing patterns, each for the specific needs. And second of all, the ability to focus only on what is useful right now, that is an advantage, without planning immediately the complete model of data structure, could be a weak point if, for example, we want to introduce later projections containing data that we have not collected in any way before. So the CQRS pattern does not give us any specific indication on how to solve this kind of problems. But let's leave this problem aside for a while and focus on the third technique that can help us in developing our application, that is the event sourcing. So event sourcing, as we know, is a different strategy for data persistence. So we are not going to persist the current state of our data, but rather the sequence of events that have led to obtain this state. So the main concept of event sourcing lies in the fact that the model is completely rebuildable from the list of events. So as a matter of fact, we must feel free to delete the model anytime and rebuild it completely from scratch. This means that the model theoretically may not have been persisted at all, so rebuild it and kept in memory if needed. And event sourcing was conceived mainly with the necessity of having a single and reliable source of truth in situations in which it is not only essential to know the current state, but also the set of events which have led to this state. Although the event sourcing does not provide direct benefits in terms of agility and scalability, it certainly provides a lot of other advantages, which, for example, the possibility of debugging a certain problem occurring in production, reconstructing exactly the events that have occurred, or the intrinsic availability of a natural form of audit. But let's straight get the critical aspect. So events represent the facts that happen over time. And since we cannot go back in time yet, we start from the assumption that events can only continue increasing. They certainly never decrease. So as it is not possible to delete an event once it has happened, but it is possible to ignore it, but certainly not to delete it nor to modify it. And this ensures that the data continues growing over time, indefinitely. As a consequence, it leads to have a huge amount of data. Managing this huge amount of data is complicated, mainly if we choose to use a relational database to persist events, which from a certain point of view risk to become slower and slower. So in terms of performance, on the one hand, we have an improvement because each update is always made up of an append that is quick. On the other hand, instead, the reconstruction of the model through all the events of the past can result in a time-consuming operation. And last but not least, there is another risk to consider. So the persistence of all events can, in some cases, degenerate into the use of all these events for communication between the bounded contexts. All store events are shared with the rest of the world. And we must pay attention to that because since the exposure of these events is equivalent to the exposure of a public API, this undermines the encapsulation of our components and favor decoupling between them. So we have seen now that DDD, CQRS, and event sourcing has pros and cons. So we can take a look on how they can empower each other. So we have seen that DDD does not give us any specific suggestion on how to behave in case of operation committing more than one aggregate. But here, the CQRS come in our aid through the definition of projections. And in turn, we have seen that CQRS has given no indication on how to initialize a projection if we had not collected all the necessary data before. But here, in this case, event sourcing comes in handy, allowing us to recreate each read model from the beginning of the time simply by tracing all events persisted in the event store starting from the event 0. So we also say that event sourcing sometimes can lead to sharing all events among all the other components. So sharing an event all over the world means supposing that our event can be correctly interpreted in all the possible contexts. And we know that this is not true. Since events are indeed part of our components API, this breaks the intended encapsulation and increases the coupling among different parts of the system. It is therefore clear that it is not a good idea sharing all events with the rest of the world. So here DDD comes to our aid with bounded context. The bounded context is, by definition, the place where all the components use the same language without ambiguity. Consequently, it is safe sharing all events related to a specific bounded context with all the components belong to this bounded context. Instead, much more attention must be paid when we decide to share an event among multiple bounded contexts. We carefully select which events are eligible for communicating outside the bounded context. Not only sometimes, no event at all. It is good to be exposed as it is outside the bounded context. But the creation of a new event is needed as a sort of translation between the internal language and the external one. So these special events will constitute the API among the various bounded contexts, the elements that are the dependence among them, and modifying the structure of these events will break down the contract among the bounded contexts. So as a result, we must be very careful defining the events that go beyond the bounded context. So in this, we can close the circle, showing how the DDD helps in the correct use of event sourcing. So these are only some of the most important aspects that make the synergy between these techniques particularly effective. However, there are still so many aspects that we can call critical, difficult. So let's analyze them one by one, starting from the difficulties in storing events. So we have said that events grow incredibly fast, and as a result, it's not uncommon to deal with billions of events. So using a relational database to manage tables of this order of magnitude can be a problem because can be extremely slow, as relational databases are not really designed to handle properly this kind of situation. And certainly better performance is guaranteed by the use of NoSQL database, which, however, are problematic in some cases, in some situations. So first of all, we must consider that the requirements for persistence of events are completely different from the requirements for the typical persistence of the current state of the domain. Indeed, we know that only insert operations are required only in the sequential order, so only append operation. And the append of a new event for a specific aggregate can take place only after the validation of the sequential number, so that it might guarantee the consistency of the aggregate. In other words, if I have two concurrent accesses to the same aggregate that generate two different events with the same sequence number, aggregate sequence number, one of the two transactions must necessarily fail. And implementing this kind of a validation with a NoSQL database can be a problem. It is not necessary to update previously stored event, and it is not necessary to delete events. So events are normally read in two different situations. First, in the reconstruction of an aggregate. In this case, it is necessary to filter the events for the specific aggregate, reading them in a sequential order. And second, in the generation of a projection, and in this case, it is necessary to go through the whole history of events as before reading them in the sequential order. So based on what we have said, it definitely makes sense to use a dedicated tool for the persistence of events. So the on-purpose event stores, or in other words, the database that are designed specifically for storing events, are optimized to meet the specific needs of the case. And they allow all events to be read in a sequential order in a performing way. And it is possible to filter quickly all events related to the single aggregate. And they maintain performance independent from the order of magnitude of number of events that are stored. And it is possible to perform a custom search if necessary, even if they are not optimized for this kind of use. And these are the fundamental things. So there is a lot more. The implementation of a dedicated event store may contain additional features, like, for example, to tell one, the intelligent use of memory support that allows to select more performing and expensive memory for the most recent events, and slower but cheaper memory for the events that are older, and so which are not read so often. And we have seen how the use of a dedicated event store can be useful in managing the problem arising from the persistence of events. Sorry. Let's now focus on the infrastructural complexity introduced by the use of CQRS. So we have seen that we need to manage 3 different types of messages that are commands, events, and queries, and how these 3 different types of messages represent 3 different concepts. As a result, they require the implementation of 3 different routing patterns. When one component sends a command, it wants to know that it is arrived at its destination and that the receiver has been able to interpret correctly the message. Even if multiple instances are available to handle this specific command, the standard expects that the command to be handled only once, and so therefore to be routed to only one of the available instances. The events follow the typical publish-subscribe pattern. So the event is simply published to the world. The component doesn't care. It publishes it and does not expect any response. It doesn't care if there are other components interested in the event, how many they are, and when they are going to manage the event. So queries may require different patterns depending on the type of request being made. So some queries expect the response from a single component, regardless of which one it is. And if there are more than one component able to answer to the request, it is normally a good idea to choose the most performing one. But there are also other situations in which each component may give a different answer. And in this case, our intention can be to pick up all the results and then to aggregate or filter them in order to get the final wanted result. And finally, there is one more possibility represented by subscription queries. And in this case, the client, after receiving the initial valid result at the time of the request, it is also interested in receiving all the updates affecting the initial result for the entire subscription in order to update the result dynamically. So these logics of interactions are multiple, and it is potentially complicated to manage them properly. As a result, it makes sense to develop a messaging platform that allows us to implement efficiently the specific routing pattern needed to support CQRS. So, moreover, how to manage now the sense of loss of control derived from the distribution of business logic among the various components, and how to learn to coexist with eventual consistency derived from the so much wanted temporal decoupling that we have achieved thanks to asynchronous communication through events. So first of all, it depends on us, on our open-minded approach towards questioning the way of thinking used for decades in software development. So to admit how much, at least in many situations, some concepts like the absolute consistency are more needs induced by habit rather than the real business need. So the greatest difficulty stems from the fact that we are used to solving problems, realizing exactly since the beginning all the side effects that we have. It is not always true. On the contrary, with the increasing complexity of systems, this is always less possible. And the real world represents very well what happens in a distributed systems. As a matter of fact, we are not perfectly aware in advance of all the side effects that a given event will have. And to develop distributed systems is therefore necessary to change our mindset, to think in an analogous way to the real world. So adopting strategy for managing uncertainty as a normal programming practice. So failure is no longer an exceptional situation. It is a fact, that, like another one, that can happen normally, to which we must react accordingly, as in any other occasion for any other event. So if, first of all, it is a question of changing our mindset, second of all, we can and we must use as many tools as possible to monitor, inspect, and track what happens within our infrastructure inside that sort of glue between domain components that can make us lose control of the process. So we can certainly say how much powerful these techniques are for implementing complex systems and how perfectly they can be combined with the implementation of distributed systems. Nevertheless, it is not possible not to realize that there are also some negative aspects. And we can start by mentioning the additional complexity of the infrastructural code, which it is mainly visible in three elements. The need of implementing a messaging platform, or in any case, a reliable and performing way to manage asynchronous communication through messages based on three different routing patterns. The need to optimize even persistence, so taking advantage of the peculiar requirements that need to be implemented while dealing with events. And the need to implement a series of methods that allows us to increase as much as possible the inspection of the system in order to reduce that sense of loss of control caused by the reason that we have listed before. So adopting these techniques also means to make an effort in terms of changing mindset, to start thinking in a completely different way we used to. And last but not least, undoubtedly, is a challenging aspect of this architecture lies in the design of the events that becomes the focus of our applications. And so the question is it really worth to invest so much in relation to the advantages that these techniques provide? So their answer is, like always, it depends. It depends on the application domain, on the situation, on the structure of the company, on the business value that events can have for a specific reality. And each case it is a case itself, and so must be evaluated independently. Everything is a compromise, so it is always a question of balancing costs and benefits. And however, there is one thing to add. So over the years, I have been witnessing two processes that have added value to the benefits provided by the use of these techniques and cut down the cost caused by them. So it is, on the one hand, the ever-growing awareness of the business value of events. And on the other hand, the creation of various tools that have greatly reduced the cost of adopting and using these techniques. So the success of this tool has been stimulated by the hexagonal architecture that recommends keeping the infrastructure separated from the domain. So by saying this, I don't mean to keep the business code pure, to not introduce any reference to infrastructural code into it. I'd rather say that on the layout level, it is important to design our software in order to decouple the implementation of the infrastructure from its API. So the adoption of this good practice gives us two main advantages. The first one is that infrastructure implementation can be reused in many projects, many times for many projects. And the second is that the infrastructure implementation can evolve, leaving the domain completely unmodified. So a great example of this concept is the location transparency. The location transparency is the property according to which application components are not aware of the location of all the other components which they interact with. So the decoupling between domain logic and infrastructure allows us to evolve the infrastructure according to the scalability requirements, the scalability needs that emerge over the time without having the minimum change into the domain logic. So, moreover, since the infrastructure is generic, they allows us to decide to use externally developed products that can deal with the implementation of a common problem, allowing us to focus on what is instead our specific problem, peculiar problem dictated from the specific business that we are implementing. So let's take a look at the last point that I have here, that is, events are the fundamental bricks that allows us to describe the way our application behaves, and they are the real value. They are most valuable than diamond for our companies, but we must be very careful, since exactly like diamonds, an event is forever. So this means that we must always remember that once the event has been created, it must be supported for a very, very long time. We must never underestimate the importance of modeling the event as best as we can, because they last forever. So it is very important to define carefully the right messages. So choose correctly the language used naming messages, as they make part of our ubiquitous language, and the implementation can be changed more easily than language. And we must choose carefully which events can be shared beyond the boundaries of the bounded context, since any change in the structure of these events will correspond to a change in the API between the bounded contexts, so it's very important to select them carefully. And we need to choose very well the structure and the granularity of the messages in order to minimize the need of versioning events. So in Axon framework, nevertheless, when it is necessary to go with the structural modification of an event, it is possible to use a caster that let you convert the event from an old format to a new format, but it's always important to choose carefully the events in order to minimize the need. So since we need to find out the events as right as possible, we still need to do some upfront design, using the best techniques that allows us to explore the domain, to discover its real nature through events. And DDD has come a long way in the last few years, but we still have a long road ahead. And although its complexity can be quite intimidating, many challenges have already been overcome in the last decade. And I think that even if we still have a lot to learn, our journey has been made a lot smoother by the techniques and tools that has been developed recently. So we can and we should continue traveling along this road, experimenting with new ideas in a process of continuous improvement, but now I think that we can do it in a lighter way. Thank you.